Hello everyone! Have you ever wondered about the tiny particles that make up everything around us? Today, we're diving into the atom. Specifically, we're exploring the often overlooked neutron. What exactly does it do inside an atom? Let's find out. Atoms are the basic building blocks of matter. They have a central nucleus. This nucleus contains protons and neutrons. Electrons orbit around this nucleus. Protons have a positive electrical charge. Electrons have a negative charge. Neutrons, however, have no electrical charge. They are neutral. Despite being neutral, neutrons play a vital role. One main job of neutrons is holding the nucleus together. Protons are all positively charged. Like charges repel each other. This means protons inside the nucleus want to push each other away. Without something to counteract this, the nucleus would fly apart. Neutrons act as a kind of nuclear glue. They provide a powerful attractive force. This force is called the strong nuclear force. It pulls all the particles in the nucleus together. It overcomes the repulsion between protons. So, neutrons are essential for atomic stability. They make atoms possible. Another important role is in creating isotopes. Every element is defined by its number of protons. For example, all carbon atoms have 6 protons. But the number of neutrons can vary. Atoms of the same element with different numbers of neutrons are called isotopes. Carbon-12 has 6 protons and 6 neutrons. Carbon-14 has 6 protons and 8 neutrons. Both are carbon. Isotopes have the same chemical properties. But they can have different physical properties. Some isotopes are stable. Others are unstable. Unstable isotopes undergo radioactive decay. This process is useful. We use carbon-14 for carbon dating ancient artifacts. Medical imaging also uses specific isotopes. Neutrons also influence nuclear stability. There's an ideal ratio of neutrons to protons. If an atom has too many or too few neutrons, it becomes unstable. This instability leads to radioactivity. The atom will try to reach a more stable state. It does this by emitting particles or energy. Understanding this ratio helps scientists predict how an atom will behave. Finally, neutrons are key in nuclear reactions. They are involved in both nuclear fission and fusion. In nuclear fission, a heavy atomic nucleus splits into smaller nuclei. This often happens when a neutron strikes the nucleus. This process releases a huge amount of energy. It can also release more neutrons. These new neutrons can then hit other nuclei. This creates a chain reaction. Nuclear power plants use this for energy. In nuclear fusion, light nuclei combine to form a heavier nucleus. Neutrons are also produced or consumed in these reactions. They help balance the forces involved. So, neutrons are far from just being neutral bystanders. They are crucial. They are the glue. They define isotopes. They ensure stability. They drive nuclear reactions. They are tiny but mighty. Thank you for watching and learning with us today. We hope you now have a clearer understanding of neutrons. If you found this video helpful, please give it a thumbs up. Share it with anyone curious about science. And if you'd like to see more content like this, consider subscribing. Your support truly helps our channel grow and allows us to keep making educational videos. We appreciate every single one of you. See you next time.